Life is like an orchestra, full of systems, organs, cells, all working together in precise harmony. Similarly, researchers need to read a large number of papers from various resources, explore databases, learn programming languages, and utilize multiple packages to make their visualization effective. This may be frustrating and cause researchers to spend a lot of time on side quests. This is why, for the 5-day GenAI capstone project, we focused on the 2024 Nobel Prize winning discovery, the MicroRNA. We utilize Google AI Gemini with LangGraph to integrate the curated Meerkat database, ground search, and data visualization in a multi-agent architecture, making scientists' work a little bit easier.
This graph represents our agentic architecture. Everything starts with the chatbot router that will be our master agent. It will decide that if the human petition should be a SQL query, if it needs some ground searching, or if it requires to be plotted. Whatever the answer these individual agents gave is going to go through the human, and the human will decide if go back with another follow-up question or if it's going to end the conversation.
Okay.
This is our capstone project for the 5-day GenAI intensive course with Google. You can find the link in the description of this video. The first thing we need to do is the setup, to remove conflicting packages and make sure that all the libraries are in the versions that you need them to be and they are compatible with each other. Our first node is a router. It's going to be in charge to determine which agent should do which task. We are using the Chat Google Generative AI with the model Gemini 2.0 Flash. Doing so, we just have a generic agent. When we actually add the instructions to the system to behave as a MicroRNA assistant, and we define the exact way that we need the outputs, following with the few shot technique, adding some examples to improve the quality, then what we have is a node that is going to be capable of telling us to which agent we should go next. Our next node is a SQL node. This one will have access to the database and will have functions that would allow it to interpret what's going on in the database. Each of these functions have the capability of going to the database and get the exact query that we are asking for. In this case, the agent will be the responsible of generating this query. We do that by integrating on the tools of the agent, its instructions with their examples, and now what we will have is an agent that, given a question, is going to go to database calls and give the answer. The next node is the literature research node. For this one, we are using Google search that is going to go a ground search on the web. The output is actually pretty nice already, but we can improve it. Ground search gives you actually the sources of the data. So using some functions for the formatting, we actually can get the response and exactly from which part this information was obtained. What is critical when you're talking about research. And if they click in any of the links, we're going to see exactly the paper where they search took that information. Our last node is the plotting node. This one will be in charge of actually executing the code that will result in the plots. We will need the tool code execution. Also, we will need a way to handle that response. And since it's not only the question, but it will also require the data to make the plots, we have the get queries to get it directly from the SQL node. With that, for example, the previous question that we did, we can get the actual plot of it. Now that all our agents are defined, we can start talking about the LangGraph. For this, as base, we're going to use the type dictionary in order to create our object graph state. This state will hold the messages that are going to be around all the interaction the tables from the SQL, the answer, biography, research queries, and a flag that will say that the conversation is over. We will make every single of the nodes using the agents that we talk about and the different handlings and functions that they may need. And we will create the logic of the ages. So these are conditional ages that then we will define on the workflow using the state graph object. We're going to add every single node and we're going to add the conditional ages. With that, we can just compile the workflow to have our new app. So when we visualize, we will see that it's the same graph that we mentioned before. We get our initial state, and that's it. We have the functional multi-agent architecture for microRNA assistance. Whether if you are interested in particular case of microRNAs or you want to build your own agents, I hope this is useful for you for your future coding. Thank you very much.